The planet Jupiter and its moons are some of the most interesting celestial objects in our solar system. We have learned a lot about the Jupiter system over the years, from storms the size of planets to volcanoes and oceans larger than our own. The planet Jupiter is 4.6 billion years old, and it was probably the first planet to start forming in the early solar system. Jupiter is the largest and most massive planet in our solar system, with 2.5 times as much mass as every other planet in our solar system combined. Jupiter is the fifth planet from the Sun and the innermost gas giant at 5.2 astronomical units, which equals 484 million miles. This means that it is about 5.2 times farther away from the Sun than the Earth is from the Sun. With being this far from the Sun, it takes Jupiter 12 years to orbit the Sun, and one day on Jupiter is around 10 hours. Jupiter is called a gas giant, also called a Jovian planet, because it is a large planet mostly made of gas. These gases that make up Jupiter are mainly hydrogen and helium, with some trace amounts of other gases. As you may have noticed, Jupiter has red and white stripes. These are cloud layers that stretch down around 2,000 miles into Jupiter. The red stripes are called belts, while the white stripes are called zones. The belts are colder, and the gases in them sink. The zones are warmer than the belts, and they rise above the belts. Jupiter also has massive cyclones. The most famous one of these is known as the Great Red Spot. The Great Red Spot has been around for hundreds of years and is larger than the planet Earth. Beneath the clouds, the atmospheric pressure is so strong that it compresses the hydrogen in the atmosphere into a liquid. Beneath this ocean of hydrogen, the pressure is so much greater that the electrons can move freely between the hydrogen atoms. This causes the liquid to be conductive and act like a metal. This is called metallic hydrogen. Metallic hydrogen is so hard to make that scientists have only made a very small amount in labs, but Jupiter is full of it because of its extremely high pressures. Beneath this metallic hydrogen mantle might lie a core. If this core exists, it would be larger than the Earth. Jupiter has the largest magnetic field of any planet in our solar system. This magnetic field is around 16 to 54 times as powerful as Earth's magnetosphere. The shape of the magnetosphere is like a raindrop. The side facing towards the Sun extends 2 million miles away from the planet. The side facing away from the Sun tapers to more than 600 million miles away from Jupiter. Now, beyond the planet Jupiter itself lies its moons and a ring system. Just like Saturn, Jupiter has a ring system. These rings, however, are small and very faint. They were discovered in 1979 by the Voyager 1 spacecraft while it flew past Jupiter. Jupiter has around 80 to 92 moons. Most of these moons are very small asteroids, but Jupiter has 4 large moons. These moons were discovered by Galileo on January 7, 1610, using his homemade telescope. At first, when he looked through his telescope, he noticed 3 bright points of light in a line around Jupiter. After observing them for a few nights, he discovered a 4th point of light. He also noticed that they moved differently than the stars behind them, and they stayed near Jupiter. On January 15th, he correctly concluded that these 4 points of light were orbiting Jupiter. This is how the first moons beyond our moon were discovered. This also helped to prove that not everything orbited the Earth like previously thought, because this showed that objects were orbiting something other than the Earth. These 4 moons are called Io, Europa, Ganymede, and Callisto. They're also called the Galilean moons, named after his discoverer Galileo. The closest Galilean moon to Jupiter is Io, and it is barely larger than our own moon. Io has the greatest gravity of any other moon in our solar system, even though it is not the largest moon. Io orbits Jupiter every 1.8 Earth days, and it only shows one side towards Jupiter. This means that Io rotates once per orbit. This is called tidal locking and is caused from the tidal forces from Jupiter. Our moon does the same thing, and this is why you can only see one side of our moon no matter what phase the moon is in. Io's orbit is not circular because Io is in an orbital resonance with Europa and Ganymede. This means that every time Ganymede orbits once, Europa orbits 2 times, and Io orbits 4 times. Io is regularly lined up with these moons and is being pulled out of a circular orbit by their gravity. When Jupiter and these moons pull on Io, they stretch and compress the moon. These tides are similar to the tides on Earth caused by the moon. However, the tides on Io are much greater than our tides. The tides cause Io to bulge by 300 feet. This stretching and compressing of Io creates friction, which creates heat. This tidal heating is so great that the interior is very hot. This creates magma and pressure, which creates volcanoes. This makes Io the most volcanically active body in our solar system, even more so than Earth. Some spacecraft have been able to image these volcanoes in the process of erupting. Io has more than 400 volcanoes on its surface. This makes Io one of the least likely places to find extraterrestrial life. The second closest moon to Jupiter is Europa. Europa is a little smaller than Io and our moon. Europa orbits Jupiter every 3.5 days, and Europa is also tidally locked, just like Io is. Europa has a very thin atmosphere made up of mostly oxygen. The surface of Europa is made of water ice. The red lines covering the surface are where the surface had cracked and had been filled in. These lines are called lineae and are likely made of water ice, salts, and sulfur. These lineae might have reacted with the radiation from Jupiter's magnetosphere to turn it red. The surface of Europa is very young in geologic time, at only 40 to 90 million years old. Similarly to Io, Europa also has tidal heating from Jupiter, Io, and Ganymede. This heating creates a subsurface ocean. This ocean beneath the surface is made of water, and Europa probably has more water than all of Earth's oceans combined. Scientists have discovered that the ocean is salty and has organic compounds in it. The Hubble Space Telescope might have discovered that Europa has geysers that are spraying water from the ocean into space. On the seafloor, there might be hydrothermal vents. This provides energy that life would need to exist. Europa has many ingredients for life like water, energy, and organic compounds. This makes Europa one of the most likely places in the solar system to find life beyond the Earth. The next moon is Ganymede. Ganymede is the largest moon in our solar system with a radius of 1,637 miles. This makes Ganymede larger than the planet Mercury. Ganymede orbits Jupiter every 7.2 days. Ganymede has a metallic iron core and a mantle made of rock. Ganymede's surface is most likely made of water ice. 40% of Ganymede's surface is covered in heavily cratered dark areas. The other 60% of the surface is lighter in color and has less craters. This suggests that the darker regions are older than the lighter regions because the older surfaces have more craters. The lighter regions on Ganymede have ridges and grooves possibly caused by tectonic activity. Beneath Ganymede's surface could lie multiple layers of liquid water and ice. The Hubble Space Telescope found evidence of these oceans and that the water is salty. Hubble also found evidence that Ganymede has a thin atmosphere of oxygen. The oxygen that makes this atmosphere might be coming from Ganymede's icy surface. When the Galileo spacecraft studied Ganymede while orbiting Jupiter, it discovered that Ganymede had its own magnetosphere. This makes Ganymede the only moon with its own magnetic field. The last of the 4 Galilean moons is called Callisto. Callisto is the third largest moon in our solar system and orbits Jupiter every 16.6 days. Unlike Io, Europa, and Ganymede, Callisto is not in an orbital residence. This means that Callisto doesn't have as much tidal heating as the other 3 moons. The interior of Callisto is not very differentiated like the other 3 Galilean moons. This means that the interior is a uniform mixture of rock and ice, and they are not separated into layers. Towards the surface, however, it is more separated. Callisto has an icy surface littered with craters. Unlike some other moons, Callisto has never had any geological activity. This means that nothing has been able to erase the craters except other impacts. This means that Callisto is the most cratered object in our solar system. Deep beneath the icy surface, there might lie an ocean of water. It could be warm enough down there for water to be liquid, but we still don't know. If there is an ocean, this means that there could be life beneath the surface. The Galileo spacecraft detected an extremely thin atmosphere of carbon dioxide. Even though Callisto may appear to be an inactive ball of ice and rock, it could be a lot more interesting than previously thought. Jupiter, Io, Europa, Ganymede, and Callisto are still very mysterious. We still don't know what the interior of Jupiter is like exactly, and whether or not it even has a core. We also still don't know a lot about the oceans on Europa, and if Ganymede or Callisto even have any oceans. These oceans could support life, and might be the best place to find life beyond the Earth. There are current and future space missions to these moons to learn more about their composition and oceans. Even though we know a lot about Jupiter and its moons, there is still a lot more to learn from them.